what we're doing here is we're taking two inequalities and combining them. And in the first case here, on the left, you can see that this equality here, x is greater than or equal to 3. We start at 3, fill it in because it says or equals, and we go greater. And this one says x is less than or equal to 7. And that's filled in at 7, and that's this way. And there's overlap here in the two graphs. In fact, the place where you overlap is the place where you can be greater than or equal to 3 and less than or equal to 7. And you can imagine that that makes sense. Let's say that this is the age at which you can be in some kind of preschool or kindergarten group, right? You've got to be greater than or equal to 3 and less than or equal to 7. It's possible to be in that span meeting both of those conditions. That's and, okay? This is a compound inequality with and. Sometimes there's a situation or, such as x is less than -2, which is over here, or x is greater than or equal to 1. It's impossible to be both less than -2 and greater than or equal to 1 at the same time. You're either in one group or the other. And so this is an or situation. If you can meet one of those two conditions, you're either here or you're here, then you're good. And that's a solution because it says or, okay? And I gave the example for or of movie tickets are half price if you are younger than 12 or 65 or older. You can't be both, but as long as you're either one, you qualify for the discount movie tickets, okay? Now, I'm gonna show you a technique here before we move on. This is just something that I do, which is this. If you wanted to write this as a compound inequality like they have here, down below it says, for and, you can write it as a single inequality where x is in between the lowest and highest numbers. And I'm going to suggest this method, okay? You have the number 3 here. Let's write it there as 3. And if you are above it, x is above it, you're going to put x on the side that's shaded, okay? And so you would say, and by the way, the alligator is always pointing to the right because it's always pointing towards the bigger number. That's how you would write that. Here, for the blue one, you could write this as, here's 7, x is in the shaded side to the left of it, so we write x over there on the side that's shaded, and the alligator always eats the bigger number, and that's that, right? So you can see that we could combine those two and say, if we were going to continue to do that down here, we'd say here's 3, x is on this side of it, here's 7, x is on that same side of it, and the alligator is always pointing towards the bigger number to the right, and that's how you can write it as a compound inequality, okay? With or situations, you can't write it as a compound inequality. You have to write it as the two separate things separated by or, okay? We'll also talk about inclusive, because if it includes the endpoint, it will say or equals. And so if I said, you'll actually see an example of that in a minute, okay? Let's keep moving. So what compound inequality represents this phrase? And then we'll graph it. The first one is all real numbers that are greater than -2 and less than 6. Let's take a look at how you do it, okay? We've got n is greater than -2 and n is less than 6. If we switch the sides of these so that the alligator was always pointing to the right, which it should be because alligator eats the bigger number, and on the number line, bigger numbers go to the right. So we can switch the order of it, and you can see that n is greater than -2, n is also less than 6. Since it's right there in the middle, you can combine these together, okay? And it is, n is greater than -2. There's -2, not filled in because it doesn't say or equals, and greater, but also we have an endpoint at 6, and we're talking about less than that. So it's this in-between spot here. This here just says, why can you write an and inequality with the word and put it together? The compound inequality has n being both greater than -2 and less than 6, and it's possible to be both at the same time. And so you write and, meaning you need to be this and that, okay? Here, all real numbers that are less than 0 or greater than or equal to 5. What does that look like? Oops. That looks like this, okay? They use t, doesn't matter, but you have values that are less than 0, that's this piece, or greater than or equal to 5. You can't be greater than 5 and less than 0 at the same time. You can be one or the other, so you just have to meet one or the other condition. T is less than 0, t is greater than 5, and if we use the method that I said in the last video, we can say here, once we've gotten those endpoints here, we can say -2 is that number, and we're talking about n in this case being shaded on the right-hand side of the -2, not including it, okay? And 6 is here, and n is to the left of it, not including it like that, okay? Over here, we could say, okay, if 0 is the number, and t was shaded on this side of it, again, alligator's always pointing to the bigger number that way. And here we could say this is 5, let's put t on the side that's shaded and make the alligator always be in that direction, that is or equals, and those are the inequalities. This, by the way, oops, here, this is the same as this. We've just got them switched and the inequalities switched as well, okay? So let me get my writing out of there real quick. And what do we have as your got it problem? Okay, there's 3 parts to this. See how you do on each part. And by the way, I just wanted to point out here that where it says inclusive means the endpoints count. So the difference between x is between -5 and 7, which would look like this. X is between -5 and 7. And the next one, x is between -5 and 7. Inclusive means include the endpoints as solutions, make them or equals. Okay, so this first part here says that a solution of a compound inequality involving and makes both inequalities true. And one way to do it is to separate it into 2. And I added this part that was going to follow, which is that you can also work all 3 parts at the same time. And that's how I'm going to be doing these. I'm going to show you these. Okay. The first thing I'm going to do, though, is show you what they did, which is they split it into 2. They said we could write this part as its own inequality right there. And then we could do this part as its own inequality there. Do them separately and then put them back together again. And yeah, that's one way you could do it. Okay, but I'm going to instead show you how to do it where you don't take them apart at all. And that looks like this. You just work each part separately. So we have this original inequality, and then we can see we're undoing, just like normal, we're undoing what's happening to the variable. In this case, the variable has 4 being subtracted from it. So how do we undo that? Well, we write what's originally there, and we have to add 4 to all 3 sides. Plus 4 says less than or equal to m minus 4 plus 4, which is less than -1 plus 4. There are 3 parts of this, 3 sections of this, one right here, and right here. So we have to do that plus 4 to all 3 parts, with the goal of making the -4 cancel out to undo what's happening to m. So when we simplify that, we get 1 is less than or equal to m, which is less than 3. And if we were to take away what they had there, you would see that they came up with that same inequality that we did right here, right there. And that's how you graph it. Okay, so what you got a problem? That's it right here. Undo what's happening to y. You can see two things are happening to it. Write it down and then make a graph. Okay, so this is suggesting that when it says or, you have to solve these separately. And you already know how to solve inequalities that are not compound, but they're just like this. We've been doing that. Okay, so what does it look like when you actually do this? Okay, we do each part separately. You subtract 2 from both sides, and then you divide both sides by 3, and you get t is less than -3. Here, we undo that plus 5 with a -5 both sides, and then you see here the coefficient is -4, so right at the step where we divide by a negative, this inequality switches direction. Don't forget that, okay? And we get t is greater than 1. So t is either less than -3 or greater than 1, and that looks like this graphed, okay? So here, try your got it problem. Okay, one last bit of this is that we're going to learn interval notation, okay? This inequality, such as x is less than or equal to -3, describes a portion of the number line called an interval. An interval is like a span of, in this case, numbers on the number line. And you can use interval notation to describe that span or that interval, okay? And so these are the special symbols, okay? Parentheses, when it's not or equals. Brackets, when it is or equals, and I'll talk about that in a second. And then we've got positive infinity and negative infinity, because if numbers keep going for forever, there's no end to them on that side, okay? So this is what it looks like. Oh, and negative infinity, same thing on the negative direction. So this is what it looks like. X is greater than or equal to 2. So what we do, we put an endpoint at 2 and we fill it in, and we say everything greater than that. So what this notation says is from 2 all the way to infinity. That's how you can read that. But this bracket, which is this, says, yeah, 2, include it. Okay, and what I have been telling kids to think about is bulging away from the number means don't include it. And you can't include infinity because it's not a number. It's just the idea that there's no end. All right, so you can't include the end if there isn't one, so that's bulging away. Okay, so the next one says x is less than 2. So you put an endpoint at 2, you don't include it because it doesn't say or equals, and you put everything less than that. And there's no end to it, it just keeps going less and less and less forever. So you get negative infinity, because that's the low end of it, all the way up to 2. Okay, so this whole span is basically describing what's shaded. And there's no end to it, so it's negative infinity, all the way up to 2. And since it doesn't say or equals, you never include infinity or negative infinity. It bulges away from those numbers, or those, and here it also doesn't include 2. So it bulges away from it saying, don't include 2. I'm not getting close to 2 because it doesn't count. Now, here, you're saying x is greater than 1, less than or equal to 5. And so when you shade that, you say, okay, we've got an endpoint at 1, we've got an endpoint filled in at 5, and x is all the in-betweens. So we have an interval from 1 to 5 on the number line, from lower to higher, and then we bulge away from 1 because it is not included. We can't count 1 as the set, part of the solution set. Okay, but 5 we can, so we just have a regular bracket saying, yep, we can get close to 5 because 5 is a number that's in. If you had it as a compound OR situation, you'd have to write it as 2 separate things, okay, where we have the low end is negative infinity, so we go from negative infinity all the way up to -3, but don't include it. So it's got parentheses, don't include that, don't include that. Or x is greater than or equal to 4. So starting at 4 and including it, so we've got a bracket all the way up to what? Keep going to infinity, and we can't include that because it's not a real number. Okay, this one last bit, and I know this is all a lot and it's challenging, but let's see if we can keep it together here. What is the graph of this? And how do you write that as an inequality? Well, how do you write it as an inequality? It first helps to read it aloud. This is saying all real numbers that are greater than or equal to 4, because the bracket says it's coming close to that and not bulging away, meaning -4 is in. So all real numbers that are greater than or equal to -4, but less than 6, because we're talking about the interval in between these numbers. So what's the graph of that? Well, again, we are talking about the interval between those values. So we've got this span here, and 4 is included. It's got a bracket that means that that is included. That's an endpoint. And bulging away from 6 means nope, nope, don't get near 6, because 6 is not actually, I mean, you're near it, but you do not include it. Don't touch it. It's not part of the set. Okay. And the interval notation then is this, and you write it as an inequality. X is all the values between this lowest point and this highest point, including this lowest point, so or equals. What about this next one? What is the interval notation for this or this? So kind of helps to graph it. This is what it looks like when you graph it. You say x is less than or equal to -1. So it could be equal to -1, so we put an endpoint there, but all the values less going to -infinity, right? And here we've got x is greater than 2, so not including 2, but starting there all the way up to infinity. So since we're always writing these in order from lower to higher, the lowest is -infinity, so that goes there, never include it, so it's parentheses. Up to 1, that's all of this shaded region from -infinity all the way up to and including 1, so it's got a bracket. And then this one starts at everything above 2, so we put parentheses, do not include 2, all the way forever, so to infinity, and we don't include it. Try yours. All right, so I've eliminated a couple of these to focus on just the stuff that you need to work on, but please do these, because this is a great example of where if you would just walk away and say, I don't get it, I don't care to get it, and you stop asking questions because it's hard, you're going to run into a wall in this class really fast, and that's no way to pass it. So just know that you can understand this. It might take you some time and asking questions, and that's the way to go. Okay, good luck.